Oh, they can check it again if they need to. Oh, look, who's here? All right. Everyone check in real quick. I think we're all good. All right, we're going to go back one. Oh, shit. Let's do this. Do these work?
They should.
Oh, yeah, there's animations. Okay, there we go. All right. Welcome, everybody. Thank you all for coming out today. This is the HKN Tech Talk series. This is our third talk of the semester. For those of you who have not met me before, my name is Ethan Hoban. I'm the president of the Eta Kappa Nu, also known as HKN, chapter on campus. HKN, is anyone here familiar with IEEE? Okay. For those who aren't, that's the Institute of Electronics and Electrical Engineers. Eta Kappa Nu is their honor society. So I'm the president of the Electrical and Computer Engineering Honor Society chapter here on campus. So if any of you are electrical computer engineers, eventually, if you do good enough in your classes around your junior year, you'll get an email from me requesting you join our organization. And there's a whole bunch of perks with that, but one of the things we do is we sponsor this Tech Talk series where we bring in professionals from across the street, aka industry professionals in defense and other places like that, to talk on various topics. We've done stealth, we've done generative AI, we've done guidance and control, robotics, automatic target recognition, all that kind of stuff. And today, we're doing DevOps. And our speaker for tonight is Kevin McCafferty, and he is a senior software engineer at Lockheed Martin. And I'll let him do the rest of his introduction.
All right.
Let's hear it for Kevin.
Thank you, everyone. I am very rusty on my public speaking, so you're going to have to work with me if I stutter or forget what I was going to say. All right. So quick what to expect. I'm going to go into who I am. I assume that most of you do not know what DevOps are, which means that a good chunk of this presentation is going to be explaining DevOps. So if you came for just the defense aspect, sorry, you're going to have to sit through the whole thing. But I'm going to go into that. DevOps cycle, it's real quick. Common DevOps tools and their uses, how that looks in a classified environment, what your day-to-day will look like, and if you want to learn more. Okay, so who am I? I graduated here in 2019 with a degree in computer science at 25, so I was a little late. I am a senior software engineer, like Ethan said, at Lockheed Martin. I am the DevOps, DevSecOps team for LRHW's technical lead. So that means that's my team. I get to tell them what to do and who to beat up when they break my stuff. I am a musician, freak, and concert goer. I have been playing brass instruments and percussion.
What's LRHW?
Ooh, good point. What is LRHW? That is long-range hypersonic weapon. So we shoot a bullet-like shape very fast. The official number is Mach 5+. The actual number is classified. It's very fast. All right, so here's a couple pictures of me. That's me and my fiance right before our first date. We weren't engaged then. And my favorite cat that died this year because she ran away. Awful cat. Terrible. There's me and Sean and Ethan. We went to go see the Minecraft movie premiere where we sat in the front row like this. It was awesome. That is the way to watch that movie. That made every scene 10 times funnier. There's me and my fiance last year, right after we got engaged. I proposed to her in a butterfly garden. It was awesome. And then that's me, like, I don't know, 2018, after snatching a fire deal on some amazing sunglasses at Walmart. I was very excited. Okay, so what's DevOps? DevOps is a set of processes, tools, cultural philosophies, and it's really, a lot of it's that culture, that automate and integrate the software development and IT operations infrastructure teams. So what do I mean by IT and like development? So typically, development is kind of its own thing, or before DevOps, you had developers, and then you had IT that managed your infrastructure. These guys did not talk very often, and then stuff broke, and then they yelled at each other. It was awesome. It was a great way to get things done. That's why we got rid of it. I'm kidding. It was a good thing that we got rid of it. It was terrible. So inefficient. So it's characterized, DevOps is characterized by three key principles: shared ownership, workflow automation, and rapid feedback. And it's basically meta engineering, right? This is a little funny, but using software engineering to engineer how we engineer software, right? And the best part is, for those of you who haven't made up your mind, if you're what you're interested in, it's really in demand. Yeah, come on. Come hang out. Listen to me ramble. The average national salary for DevOps is about 119K starting. It's a difficult job. You will tear your hair out. That's how I lost mine. But here in Huntsville, I think it's a little less than this 100K for the defense industry, but it's a lower cost of living area. Okay, so you're gonna see this picture if you study DevOps all the time, and you're gonna see it with 5 little segments, 8 segments. I've seen some with 10. There's tons of variations, but this is the most general one. This is the most common one you're gonna find. So it's plan, code, build, test, release, deploy, operate, and monitor. Okay, so planning is, what are we gonna do? Code is, please write the code, right? Build is, okay, I wrote some code. Let's make sure it compiles and exists correctly, right? Test, okay, cool. This is where stuff gets a little bit more interesting. Okay, I've built my code. Now what? How do I know that it works right? Well, you gotta test it, right? So you usually write unit tests, you've got integration tests, you've got all types of stuff. Sometimes you have a testing team. Most of the time, though, on smaller teams, it's gonna be the software guys who write the test, but it is part of the DevOps cycle. DevOps cycle is not just it's not just the DevOps team's job, it's everybody's job to be following the DevOps cycle and to get into this mindset. It is a team-wide cultural thing. Program-wide is what we'd say for the defense industry, program-wide. So now we got release. Ship it somewhere. Cool, right? Deploy. Deploy is, okay, I've got a test environment. Or if you're really actually insane, you just deploy it directly to production. Not many people do that for good reason, but if you want to and just, suffer potentially, you can do that. But deploy is you ship it off to a testing area for where people can mess with it. Operate, get some users in there. What's it look like? Does it work? Can you still tweet if it's Twitter, right? And now monitor. All right, so operate is really kind of also past that test area. Go ahead and push it to production, right? That's included in operate because now you got your users using it. And then you got monitor, which is, okay, we passed all of our known tests. We tested it also manually. Looks pretty cool, right? Now let's just watch it like a hawk and see if, anybody's found a buffer overflow error or something. Okay, so why do we practice DevOps? DevOps and other star ops, you'll hear stuff like FinOps, which is financial operations, SecOps, which is security operations, GitOps, which is fake. Just kidding. It's managing Git repositories and stuff like that. Streamline and automate what we do. Huge, huge boon to productivity. So, as an aside, on GWS, he was there, we saved untold engineering hours by implementing code and build scan pipelines that just ran automatically. Didn't have to think about it. And then further optimizing these things over time, we saved, by my calculations, about 40,000 engineering hours just in one update. So DevOps also helps standardize our processes, which reduces errors, which is a big thing because if you've ever shipped anything to the government, they really hate it when their stuff doesn't work. They really hate it. And then they come back to you and they say, we're not going to pay you until you fix it. And then your C-suite leadership goes, fix it. And then they make you work 60-hour weeks. It's awesome. But too long, didn't read this, is we use DevOps to save money, save time, and prevent errors. So how do we do it? DevOps is mostly a cultural thing, right? But there's a lot of tools that help us do that. So these tools can be broadly categorized into a few different groups. So issue tracking, collaboration, which is also like project management, change management, version control. So that's, keeping all your versions separate, making sure you know what's coming down the pipe. Build systems, which is how do you build your code, right? You can't just turn source code into the government and go, check it out, dude. Here's a C++ file. They're gonna be like, great. What's it do? And then they're gonna look at you and you're gonna have to sit there and explain to them that you didn't build your code. They wouldn't like that. CI/CD automation, which is continuous integration, continuous development. So that's like pipelines, any type of automated task. You got infrastructure provisioning. So what's all your stuff run on, right? You need servers, you need desktop computers or laptop computers, you need a network switch at least, right? You need all types of stuff. And then containerization. Containerization, we'll get more into it. It's not super caught on in the defense industry, but containerization is like, it's kind of like a virtual machine. I'll get into that. So all these tools help us fulfill that DevOps cycle. So here's that infinity sign, the DevOps cycle again. Here's a bunch of tools. You guys can look at this later. I'll ship out the slides, but these aren't even like probably a fourth of the tools just I've seen, right? So there's lots. Okay, so I'm gonna go into kind of what these concepts are, and then we'll kind of get more into what it looks like in the defense industry. So issue tracking, project management. All right, it's the most important part of any software development cycle because you can't, how do you know what you're gonna write, what software you're gonna write if you don't know where you're trying to go, what's already been written, when the customer wants stuff, or any type of schedule plan. So these softwares, kind of here, they're examples, but they're the most core part of the planning phase of the DevOps cycle. So most common that you're going to see, especially in the defense industry, are Jira. It's the original. It's part of the Atlassian suite, and you can see I left a little comma there. It's pretty cool. Apostrophe, sorry. GitLab, it's a one-stop shop. It's becoming much more popular very quickly. You got Monday.com, which is used by Canva, which I'm using to prevent, and some other places. Basecamp, literally never heard of it. And then GitHub Issues, which in the defense industry, you probably won't see too much about that. More on that later. Okay, version control. We're actually getting into real software here. This is how it's a software engineering practice of controlling, organizing, and tracking files. There's tons of version controls, like infinite version controls. Most of them are bad. But here's some examples you'll probably run into. Definitely Git. Git has like 90-something% of the market. Like, it's free, it's open source, it's written by Linus Torvald, which computer science guys, yep, see, he knows. That's the guy who made Linux. He's good. He is kind of mean though. He does make people cry quite a bit. Subversion, which is like, imagine Git, but kind of worse. And Git prevents you from just going, okay, hey, I'm just gonna like merge to master. I'm gonna, when I push my code, straight to prod, straight to production, right? Subversion is like, that's fine. No, that's actually encouraged, yeah. It's trunk-based development. Everybody, when you commit something in Subversion, it goes straight to everyone else. It's really bad. Mercurial, which I think Mozilla uses Mercurial, and it's an older thing. There's some stuff out there. And then ClearCase, the only people that use ClearCase are like really specific researchers and anybody over 100. So if you run into ClearCase, know that whatever defense contract you're on, because God knows that literally nobody else in like the regular software industry is using it, just know that that program was probably invented in the Civil War. So, you know, prep for muskets. All right, cool, keep going. We use these version controls with remotely hosted repositories, meaning like where your code is stored is like on a server somewhere, right? We use these, and the version control software is the interface on how you get to it, right? So you use Git to get to your remote repository. Haha. Git to Git. There are a ton of different source code repository hosting softwares. Here's 3 of them. I'm sure you've heard of them. You're gonna see GitLab all the time from me. It's very popular. Bitbucket, if you prefer the Atlassian suite, which I don't know why you would, but it's there. And then GitHub, which I'm sure a lot of people are familiar with. Okay, it's really important. That's why there's 3 slides on this. It's important because work may be ongoing on multiple versions of your software at the same time. You might have multiple people working on different versions, is what that really means. Multiple people might be working on the same file. Let's say you've got a bunch of dudes, bless you. If you sneeze again, I'm coming for you.
Okay.
Just messing with you. You might have multiple people working on the same file, right? Let's say you got a story, which is how we track our work. You got a story. And two people have two different stories, and they both involve the same file. Probably need to have some sort of version control software to make sure that when those guys go up, the changes are kept from both, which is something Git helps us do. And it keeps track of changes and their timeframes to help you find bugs. So like, whenever I was looking for a bug, the first thing I would do on GWS would go look for Ethan's commits.
Rude.
It's not true. It was the other way around. He'd go look for bugs and they would be mine. Without version control, programmers would lose track of all this kind of stuff. Oh, and that graphic was basically how it works. It's what it looks like. Okay, build systems. This is my bread and butter. This is what I do. I love build systems because, again, I like going bald. It makes you want to tear your hair out. The shinier my head, the more reflective it is, and the more I can use it during road rage to blind my opponents. All right, so what's a build system? What does that even mean? So it's a tool or a set of tools and processes that automate taking your code and other things that you might build into it, right, into an actual like executable or a library file. So what that means is you ever double click something on a Windows computer, right? Everybody's done that. That's an executable. You ever seen on a Windows computer such and such DLL is not working? Yeah, right? That's a library. It's a shared object library. There are different types, but that doesn't matter for this. Okay, so build systems, gotta have them. You literally can't code without them. Here's some examples. Mine, the one that I know the most is CMake. It's great, it's wonderful. It can be very annoying. It's old. It's actually new, but it's based off of GNU Make, which is very old, ancient. But that's Apache Ant and Gradle. Gradle can build C, and CMake can build Java, but Gradle's mostly a Java thing. Apache Ant's mostly a Java thing. Maven is mostly a Java thing. I'll be real with you guys, I forgot what the symbol for that one is. And then MS Builds for Visual Studio, which, if nothing has changed, you guys are still using, computer scientists, use Visual Studio?
Yeah.
Great, that's MS Build. It's Microsoft. All right, here's an example. Really basic examples, by the way. Like, this is not what you will see in industry, but the left is CMake, the basics. The right is Gradle, and you can kind of see who's influenced what, right? This is CMake. I'll come over here. CMake is a lot more Bash-like. Anybody use Linux? Yeah? Okay, cool. This looks like Bash, right? Kind of. Little off, but it's mostly Bash. This looks like Java. So if you like this, you're wrong. The world runs on Java. Well, all the things that are broken, at least.
Okay.
I'm done. I'm sorry. All right. What's CI/CD? All right. Continuous integration, continuous deployment, or delivery. However you want to phrase that, it's fine. Refers to automatic building and testing of newly written code. So it's done. You always have a pipeline. This is done by pipeline. This is all pipeline. CI/CD is pipelines. And what's a pipeline? It's a script. It's basically a script that runs on like build. So when somebody pushes code to a remote repository, like if they do git push or svn commit, pipeline will run. And it goes, okay, cool, I see this code. That's sick. I'm going to build it. It's a great little check, right? And it may have some tests. You may just have some unit tests. You may have integration tests. You might have a lot of different things in there. But you do it to check, make sure the code is good. Continuous deployment part is both part of the testing and release stages, because you might have this code deployed to a test stage, right? So that's kind of test. But it might be deployed just not for the pipeline to use. It's probably deployed for somebody to go take a look at. So, releasing software, public location for access. So that's like, you guys, anybody use Microsoft VS Code? Like, yeah, you know, they have tons of plugins. That's the CD part. When those guys finish making something, they're like, all right, sick. Shoot it over to Microsoft. I can't remember what that host website is called. I think it's just VS Code. All right, CI/CD tools. So I already covered what a pipeline is, but here's some CI/CD tools. These are the two. This is what you're going to see if you do defense. GitLab and Jenkins. But some other ones are GitHub Actions, which I've never used. The AWS Code Pipelines, also never used. Azure Pipelines, did use that once. It was Microsoft, so I had feelings about it. Okay, here's some pipeline examples. The right is Jenkins. The left is GitLab. GitLab uses YAML. Anybody kind of know what YAML is? Yeah, it's yet another markdown language. It's there. Jenkins uses Groovy, which is Java-based, and really it's not Groovy, but we're just going to call it Groovy for the sake of this. Okay, cool. What's infrastructure? What I'm using right now. That's what infrastructure looks like to, I guess, people who make graphics, because that's not really what it looks like. It's a lot dustier in real life. All right, so all these tools that we're talking about have to run somewhere, and the developers have to have a computer to write code on. They're not etching it into stone tablets, right? Or like my mom did back in the 70s, getting a punch card and punching the card with her code, and then taking it to a mainframe computer and standing in line with 30 other software developers, and then waiting for the Fortran machine to work. She loves telling me that all the time. She's like, oh, Kevin, we used to have to do punch cards. I'm like, Mom, you're ancient. Like, did you know George Washington, not Bush? Shut up. I would never tell my mom to shut up. She'd kill me. Probably. She is old. She probably couldn't catch me if I ran. All right. So infrastructure is also like all the IT components, servers, networks, network switches, firewalls, cloud environments, if you are using the cloud, that runs applications, or not. Maybe it's just sitting there doing nothing. It's still part of your infrastructure. You better monitor it. Okay, so what's infrastructure as code? Nothing works without your infrastructure. So what happens if your infrastructure stops working? This is where infrastructure as code comes into play. Infrastructure as code is the practice of managing and provisioning IT, network, cloud, and other infrastructure through machine-readable definition files and applying software development principles like version control and automation to infrastructure deployment. So what does that sentence that I totally did not use AI to help me write mean? It means that you save all your configurations for your infrastructure in some sort of file that defines what your infrastructure really is. It allows for fast deployments of new infrastructure and fast recovery, because time is money, right? DevOps is all about saving money and going fast, smartly. All right, so what are the tools that we use to do IAC, infrastructure as code? There's tons of them. There's really tons of them, but there's really only four that matter. And I included one that doesn't matter. So Terraform definitely matters. Pulumi kind of matters. It's a Terraform competitor. AWS CloudFormation matters if you're doing cloud. And Google and Microsoft's equivalent, they have the same thing. It's the same thing. Ansible, which is kind of infrastructure as code. It's more configuration as code. I'll touch on that in a second. And Chef, which is the same thing. So Ansible and Chef, like I say, they can be configuration as code, but it fits within that concept. And what I mean by that is Terraform. Actually, let's pull up that example. No, go back. All right, Terraform, if you can see here, right? This is this guy. This is Terraform. What he's doing is he's literally creating a container. He's creating it. This guy is already on an existing machine and saying, oh, hey, this is what I want you to look like. This is your configuration. So you kind of see the difference. He makes it and configures it. This guy can just configure it. Ansible's capable of a lot more than that, but for the sake of this, that's their main difference. You're going to see Ansible everywhere, and you'll probably see Terraform everywhere. Cool. So what's a container? Great question. Some people, nobody really knows. That is a cat in a Docker container, though. that I didn't have AI generate. It's fine. All right, so they're standard and lightweight packages that contain a program and everything that program is going to need to run. Containers provide consistent, isolated environment. Isolated. It's more isolated. That allow applications to run reliably and identically across various computing platforms. So great thing about containers is if you build them for a Windows or a Linux or a Unix or a Temple OS, whatever. I don't think Temple OS has containerization. You guys can check me on that. That application doesn't really have to change inside that container. That container handles that interface between the application and the operating system. All right, so containers, they don't talk to each other by default. You can totally get around that. It's no problem. But if one container should go south for any reason, from hacking or crashing, the effects of this incident do remain quarantined, whether they're talking or not, to that single container. Containers are a huge part in solving scalability problems. You guys ever been like watching something and it goes down, right? Like the whole website's like YouTube during that whatever fight, or Netflix. It's like Jake Paul versus, right? And it just kept crashing. It's because they literally could not spin up enough containers to handle the amount of people trying to watch that. So there's software specifically developed to help that, like Kubernetes, which I don't cover here, but we can get to that later. You can ask me later if you want to know. All right, so some containerization softwares. There's really only two that are big boys. Everything else is much smaller. And there's really only one. And that's the king. It's king himself. That's Docker. It's the whale. You've probably seen him around. Two is Podman. Podman is like Docker, but free and open source and run by Red Hat. If you guys have ever heard of Red Hat. Containered, which is what Docker's built off of, or Podman. One of them is built off of Containered. LXC, which is Linux's container stuff. I don't see it too often, but it's there. Cryo. I forgot what Canico was. I obviously didn't find its logo. Otherwise, it'd be there. Docker is the most dominant of these. I mean, I think I didn't put the percentage, but I think it's something like 90-something% of the container market is Docker. That's what you're going to see. Okay. So a lot of times when people say containers, they're like, oh, they're like virtual machines. Because it is kind of like a virtualization in virtual machines, but containers aren't virtual machines. They're not the same thing at all. They can fulfill similar purposes, but they're not the same. So that, again, while they offer some of the same benefits as virtual machines, even some of the same governing ideas, they're extremely different in how they function. Virtual machines can run their own, they do run their own complete operating system. They are very resource intensive and require usually server level hardware to get meaningful virtual machine performance. And one of their few benefits, I guess, is they provide complete isolation. They are completely isolated. There's no shot of a virtual machine talking to another virtual machine or their data getting mixed up because they're on their own operating systems. They're their own computer running on the same hardware. Containers all run on one operating system, right? They're like on top of it. So if you look here in that graphic, there's this hypervisor layer. That's how the guest OS talk to the actual computer. But here, all of these apps are on the same operating system. But they all use this container engine, which would be your Docker or your Podman, to kind of talk to that infrastructure that they're on. They're much lighter weight, and they provide some isolation from the host and other containers. Here's a better picture, kind of ignoring the hypervisor. So this is a virtual machine. They're all running inside their own OSs, right? They got their own kernel. Not these guys. These guys are just chilling right next to each other. But inside of here is everything that this app needs, or these services need to run. All of it. Which is what makes them so convenient. And it's what helps, actually it's the only thing that gives them their ability of being so easy to move cross-platform. When I say cross-platform, I mean between Linux or Windows or different distributions of Linux or different versions of Windows. Because you can just take everything that app needs, throw it in a container, and then ship it out the door and not think about it until a user comes back and says it doesn't work. Okay, so I've covered a ton of concepts. I'm sorry if it was like a fire hose, But I need to get through all that so I could tell you what does DevOps in the defense industry look like. All right, whatever the rest of the software industry was doing 10 years ago. Thank you, that is my TED Talk. Thank you guys for coming. It's been great. You guys go ahead and sign out. I'm kidding. Okay, in all seriousness, the defense industry has a lot of unique challenges when it comes to DevOps. Ridiculous amount. And there's a ton of rules, should say guidelines, because you could usually bend them, you know, if you grease the wheel. I don't mean paying people off. If you're just nice to the IT people, or I should say the IA, Information Assurance, or cyber guys, nobody's nice to them because they tell people no all the time. They'll eventually go, well, I guess, Kevin, you can have that Chinese AI on the classified system, right? You want to connect the classified system to the internet? I guess. You want to watch YouTube? I get it. They don't let you do that. They'd probably kill you, actually. DCSA would be breathing down their neck. All right. So while some of these upcoming softwares might be able to be used on the unclassified or low side network, many defense programs do all of their work on a classified network. So getting these tools onto the high side, the classified side, can be a bit of a pain, right? Some of these more traditional tools, that's your Docker, your GitHub, your, oh man, there's so many. I just can't think of them at this moment. So anyway, some of your plugins for VS Code, they don't qualify. Why? Because they were developed by a foreign national foreign adversary. So like somebody who's Chinese or French. But I mean, I know we're allies with the French, but nobody likes them. So they don't qualify. Software that requires elevated permissions to run. Docker. Docker it requires you to have sudo. You have to, and the general user does not have sudo privileges. So softwares with licenses that require any of the changes that you make to the code to go back up to the code's repository. That's like the GNU app something 3, you know the license. Makes you, anytime you modify that software, you have to push it back up. Can't use anything with that license. Software that can give network visibility, so like the ability to see what's going on in the network to a non-elevated user. So you'll find that on your classified IT or your DevOps, DevSecOps teams, but like to a normal user, they don't have access to that software. Same with this snooping. That's like Wireshark snooping or network scanning. So there's some tools that can be used to scan your infrastructure for vulnerabilities. That's not going anywhere. That's probably on one machine on the classified network and like 14 padlocks and like a alligator pit, right? And one dude has tamed the alligators and he can go over there. Very, very secure. Okay, so this kind of leads me to my point. Tools, what tools? You don't get them all. You don't get all the fancy stuff. You kind of got to deal with whatever industry was using 10 years ago. And the more cloud services become normal 15 years ago. So, common tools, I already mentioned Wireshark and Docker, but anything that requires a internet connection. So that's your GitHub. No GitHub, there's no self-hosted GitHub, because you can't self-host it. So most things can't be self-hosted. So there are some exceptions. So like cloud services can be available through like Microsoft Azure classified cloud services. Man, say that 5 times fast. Super uncommon. It's very expensive. It's kind of stupid. But some programs are into it. They love it. So open source software used to be impossible. You could not have it. It was considered insecure. Yeah, I know. That was about a decade ago, though. Over time, the United States military and DoD, they've kind of reversed course on this rule. And they actually prefer it. They actually want open source software. That's what they want. We have an entire thing at Lockheed Martin called EFOS, Enterprise Free and Open Source Software. Anything that passes those cans, it's automated. It grabs open source software if you put it in there, and then it will continue, if you set it up to, get updates for it. And if it passes its scans, it's good to go. All you got to do is go to your IA lead, which is your information assurance. Right? Those are your cybersecurity guys, and go, CyberDad, I would like this software. And hopefully they will bless you with the software. Although some cyber leads, they don't like doing that. They just like to watch you suffer. our sister program, Conventional Prompt Strike, has that problem. Their cyber guys approve literally nothing. In fact, they approve so little that they use our infrastructure. It's great. I love having my infrastructure that I'm supposed to use being used by somebody else. Super cool. Okay, so substitutes for common tools. Already mentioned Podman, right? Podman, Docker becomes Podman, GitHub becomes GitLab or Bitbucket. Classified cloud services, already covered that. Any Java people? They usually teach you C++ here, right? Still? Okay. Anybody ever done Java? Maybe a little bit, right? Did you use IntelliJ as your?
Actually, no. Here we mainly used Eclipse. They made us.
Great, because IntelliJ is illegal. It's Chinese owned. Can't have it. Oh yeah, and by the way, I made the same face. I wanted it because we were doing a little bit of Java, and I was like, oh, IntelliJ was so great. And then they just sent it back to me like, no. I was like, a single tier. And I was like, I'm just not gonna write Java, which actually made me much happier. Okay, Docker versus Podman. Most of the time for developers on the classified system, and I've said this over and over, you're gonna see Podman. Podman, Podman, Podman. Why do you see Podman so much? Because most classified systems on Linux, and most of those are running RHEL, Red Hat Enterprise Linux. It's a private distribution of Linux. It's more secure, supposedly. So Docker relies on a daemon to maintain and manage containers. This means in order to use it, you gotta have that elevated privileges. This is a problem because the bare minimum requirement to get elevated privileges on a security or on a secured classified system is a security plus certification. And the higher up you go in the classifications, the more likely they're just not gonna give it to you, period. Like you can come into them with a CISSP, which is a very, very premium cert. And if you're not on the right team, they're gonna say, you're a regular user, sorry. No daemon control for you. Podman is daemonless and rootless, which means that you can just run it. It's good, it's no problem. And Podman is really great because it was developed to mimic Docker. It's like the same thing. It even uses the Docker file extension, and the command line is almost the same. There's just very little differences. It's basically the same, it's great. GitHub versus GitLab. GitLab can be self-hosted, it's more robust with security and access controls to individual repositories that are hosted on GitLab. It's got, remember how I was talking about CI/CD? GitLab has like everything. Like you get GitLab, and it's expensive, just to be clear. The Enterprise Edition is very expensive. It's tens of thousands a year. But you get that, you got it all. It's all there. It's sick, it's great. As long as you like YAML, because they love YAML. That's what you do. You write YAML. There's more security out of the box too. It's got a bunch of these tools. Embarrassingly, I don't use them. I don't know. Tons of security tools though. I'm sure they do something. Probably. Okay, so now DevOps teams and classified IT. Because sometimes, depending on the program and the classified information system, which is like your network, right? What classified network are you on? The DevOps team might control your IT infrastructure, or they might not. Sometimes it's a separate IT team. In fact, actually, it's a lot of the time it's a separate IT team. So, what's that mean? Sometimes DevOps teams do manage the hardware, virtual machines, user accounts, like for the whole network, user accounts for the tools, the tool instances themselves, and the network infrastructure. And sometimes they don't. As an example, on GWS, there was an entire major team. There were like 5 major teams, right? And then sub-teams under them. But there's an entire major team with like 100-something people called G&I dedicated just to network and server infrastructure. That's all they did. So the other teams that had their own DevOps guys and teams wrote pipelines, they automated tasks, and acted kind of as an interface between that infrastructure team and the DevOps person's team or teams. On LHW, on Lockheed, we have a campus-wide classified IT team that has to be shared. It's super great when you're LRHW and you're like the smallest program. They totally pay attention to you. It's awesome. But they have to be shared, and they manage each classified network separately, and we have our own DevOps team, right? I'm in charge of it. And it works. We work with the classified campus IT team on infrastructure and tooling, but we manage everything else. All right, I've kind of already touched on this, but DevOps teams also work with cybersecurity teams. So sometimes the DevOps team also includes the cybersecurity guys. This is really common in the software industry. It's why you hear DevSecOps. Why I've been saying DevOps is because in the defense industry, we don't care about security. I'm kidding. We do care about security. There's a lot of segmentation in the defense industry. When you're working on a classified system, they like to keep these teams separate so you don't have too many people with too many keys. So that's kind of how that ends up happening. Okay, so if you are a DevSecOps team, which I kind of am, you're gonna have responsibilities like cyber sticking, which is security technical implementation guides. What does that mean? Sometimes the government, and by sometimes I mean all the time, they do their own scans of operating systems and other softwares, and they find issues that they don't like, and then they put out these guides and they say, you better fix that, or we're coming for your accreditation, which means your ability to operate a classified IT system. And so as you can imagine, that is how Lockheed Martin and Northrop Grumman and Raytheon make their money. So they are very quick to do these. Management of static code analysis tools. This is something I do. I didn't touch on these because they're kind of unimportant, but I'll touch on them here in a bit. They're like things that like look at your code and say, yeah, buffer overflow, bad syntax, you're ugly, right? That kind of stuff. Network security management, which is like making sure the network's secure. I don't know, that's my buddy John's job. He does that. Often for the defense industry, like I said, there's a lot of separation in between that DevSecOps than normal corporate software environments. Okay, so automation challenges. I was talking about how important it is to DevOps that we automate stuff. In a classified environment, it's not always so easy. So, talk about guidelines, right? A lot of these guidelines make automating stuff kind of hard. So, automating an ISO file, right? Let's say you're delivering an operating system to with a program on it to the government, right? They want a drive with an operating system on it. Well, and so you need to make an ISO so that you can install, I don't know, Windows XP onto that because they love Windows XP. Don't let them tell you otherwise. That's almost not possible because if you're doing a Linux distribution, make ISO is, you have to have sudo. You have to. There's literally no other way to run that command. You have to have root permissions. So you're not going to have a service account that has root permissions. No way. Because everybody can access that service account. Your service account would be like, so when your pipeline runs under a user. It has to, right? Somebody's got to be doing it. So that user is a service account. They're not going to give that service account elevated permissions because anybody could probably go write a pipeline, change some code in the pipeline, and then potentially add malicious code. So no root for your pipelines, illegal. If you're making, same for the Microsoft, by the way. If you're making a Windows, they have that tool. I can't remember what it's called, but it's it's the same thing. You can make a bootable USB or ISO using Microsoft stuff. Automating your deployment of your software to a test environment, something I was trying to do on GWS. Literally impossible, because in order to install the software that we made on GWS, it was designed to be installed to the machine. Guess what you need to install stuff? Yeah, that's right, it's root. Service account's not gonna get root, and you can't put your password and your user in a pipeline. Because then information assurance and cyber are gonna see that, and they'll be like, hey, Kevin, can't help but notice that last night, while everybody was gone, your user ran 4,000 commands of copying and pasting stuff into a USB drive and then left. It's like, well, that wasn't me, right? Somebody went on there, but your password's in this pipeline, and that's what allowed it, right? So other things that might make automation difficult. Your code runs on a real-time operating system. Congratulations, you're boned. Automated delivery of software to a customer. No. Well, except for one time. There is somewhere on the arsenal, I don't know the program, that they have somehow convinced the MDA to allow them to have an automated high to low transfer. Yeah, You know how absurd that is. There is a program that convinced them. I do not know who it is. I just know they're a Lockheed program, and they have some sort of machine that sits between.
them.
I know, right? How did they convince them to do this? It would be so
Hire the
great.
wizard.
Oh, it's really cool. I'm sure they will never let that happen ever again.
I spent 2 months doing that once.
So defense software here. What you did?
Yeah, recently. I mean, not like 24/7, but like,
It took 2 months.
Troy, you gotta have like 300 dudes review some of these things sometimes.
It's true.
It takes forever.
The change review boards. Haven't touched on that. I'll touch on that here in a second. Defense softwares often have a lot of other softwares to interface with. Like GWS is a weapons system. There were like 7 other teams writing software. So if you actually want to like automate the testing of your software, well, you got to get those guys on board, right? You can't just pull their stuff down. I wish you could. So, what's it look like day to day? Day to day tasking in the DevOps team in the defense industry, it's super different program to program. You never know because I've given all these variation possibilities, right? But I can tell you what it's looked like for me. So, most of the time you're gonna have build or development pipeline management updates or refactoring, the famous Devops push.
Devops.
That's what they called me. It was not a term of endearment. Build system updates, maintenance or redesigns. So that's your CMake, your Gradles, that kind of stuff. Creation of CCB changes or requests for updating existing softwares to your baseline. So if you have a VS Code extension that's version 1.1.0 and you want 1.1.1, congratulations. You have to put in a ticket with IA, information assurance, the cyber guys, and your classified IT, assuming you're not part of that, and they have to go to a review board, which meets once a month to twice a week, program to program, and they have to sign off on it. They have to go, yeah, no, that's cool, right? And a lot of times these guys aren't software people, which means that sometimes you're gonna request things, and they're not gonna get it, and they're gonna go, no. And their word is law, which means that you have to live without until they quit and the next guy comes in and then you try again, right? I'm not saying I do that. So, resolving user issues, meaning, Kevin, I locked myself out of my account. Is this the 3rd time? Yeah. You know, happens all the time. The average user, even as a software engineer, you'd be surprised. Especially the older guys. No offense to them, they're wizards in their own right, but man, they forget their passwords a lot. Nightly build systems, a lot of them, maintaining those. Maintaining and creating other automated systems, right? Applying those STIGs, talked about those STIGs, right? Applying that, it's your gig. If you're a DevSecOps team, monitoring and managing your infrastructure. If you're also, right, the IT team. Or you have what's called a tactical network. Sometimes you will have a classified network and a tactical network. They are both classified, but the tactical network is meant to mimic whatever's in the field. So sometimes you're managing that infrastructure as well, because the classified IT team, if you have one, kind of just goes, it's not really our thing, right? Because they're managing your actual network. Kind of confusing. If you do defense DevOps or just defense industry in general, you'll kind of get it. So managing the static code analysis tools, Coverity, SonarQube, those are the 2 big ones you're gonna see. All right, so how do you prep for a job in the defense industry as a DevOps engineer? Degree in computer science, engineering, cybersecurity, IS, MIS, any degree related to electrical engineering, computation, software, networking, cybersecurity, all great. All right, certifications. They will help you get a job. If you are looking to do this, they're gonna help you. Here's some good ones. Most of these are cybersecurity certifications, but these let you get permissions to do the DevOps things that I'm talking about, right? Or you could be really good with words like me and not have any of these, and they just kind of let you do it anyway. It's rare. I'm the only person I know that they just kind of let me do it, but you should have these, any of these. And even if you don't want to do defense industry DevOps, if you're like, oh, this sounds great, except when he got to the defense part, which is totally fair, I get that. Any of these, they're all great. They're all great all the time. Cloud computing would be especially good if you wanted to do that, right? If you want to do DevOps not in the defense industry, Go get your AWS cloud, go get your Azure, go get your Google. I'm sure there's other ones. Get a Kubernetes certification. All of that will just jump you to the top. I mean, assuming you don't have like a 0.9 GPA. Learn tools for the defense industry. Learn tools like Jenkins, GitLab CI/CD, CMake. Learn CMake, put that on your resume. They'll be sucking your toes. They're gonna love you. They're gonna lose their mind. Nobody likes to do CMake. There's good reason. Like I said, it took my hair from me. SonarQube, Coverity, Ansible, Terraform. No Terraform, period. If you learn Terraform, you're great. You could go anywhere. Everybody loves people who know Terraform because so many people don't still somehow. It's kind of interesting. Get involved. Unfortunately, after writing this, I learned that, as I put in here, it's not just currently on hiatus, it's been on hiatus for a year. I used to know the guy, JD Black, who ran these. He hasn't posted a meeting in over a year now, so I don't know if this is still here.
He's
but
busy.
Yeah, you guys have any questions for me? You can ask them. You can, if you want, if you like don't feel comfortable asking them right now, you can come up to me in private after. But go ahead and check out if you're done. Thanks for coming. I appreciate it, and I hope you guys liked it.
All right. Thank you, Kevin. Great talk. And yeah, so he's got nowhere to be. I have him prisoner for at least another half hour. So feel free to let her up with questions. Doesn't have to be specifically Devops related. It could be general career advice. What's your favorite song? Will you hire me? That kind of stuff.
Just don't mention any type of tanks because I will ramble for 3 hours.
Yeah, this guy plays War Thunder, man. It's a miracle he hasn't gotten his clearance revoked.